These are the examples for Geometry A, Credit 5, Lesson 13.4. Lesson 13.4, the first part on page 44, you're going to be doing what's called solving a right triangle. And what solving a right triangle is finding all missing sides and all missing angles. Now, a couple of things we're given. We're given the lengths of two of the sides. WT is 28, HW is 45. So the only missing side is HT. Also, we know that angle W is a right angle. So the only missing angles are angle H and angle T. So only three things to find. The length of HT, we'll do that first, and then we'll find angle T and then angle H. This example is for problems 1, 2, and 3, and also for 4, 5, and 6. So the example that we're going to do for number 1 will also help you out with number 4. All right, so to find HT, so HT is the long side or the hypotenuse of this right triangle here. And remember before in previous lesson, previous credit, we learned the Pythagorean theorem. Remember the Pythagorean theorem is leg squared plus leg squared equals the hypotenuse squared. And so let's go ahead and use that formula to find our missing side length, HT. So the legs, remember, it doesn't matter which one goes where, as long as we get the legs over here. The legs are the two sides that form that right angle. So one of them is 45, so we have 45 squared. The other one's 28, so we have 28 squared. And the hypotenuse is represented by x, so we don't have to keep writing the word hypotenuse there. And so we have x squared. All right, so let's start working this out. Order of operations says that we do our exponents before we add. 45 squared means 45 times 45, which is 2,025. 28 squared, same thing. We're going to multiply 28 times 28, or just hit the x squared button on your calculator. 28 times 28 is 784. Next, we're going to add the 2,025 and the 784, and we get 2,809. But again, that's not our answer because that's equal to x squared. We still need to solve for x, so we're going to take the opposite of squaring as square root. So we're going to take the square root of both sides. The square root and the squaring, the radical and the exponent of 2 cancel out. So we just have the x. And then the square root of 2009 is 53. And so HT, x, which represents HT, is 53. So let's write it like this. That's just x. So we won't box that. So our answer, 53. Now, just to kind of go over real quick, let's go ahead and show you on Desmos how you take the square root of a number. And there is Desmos. There we go. And let's go ahead and show you how we do square root. So once you're in Desmos, you're going to bring up the keyboard, and then there's the square root symbol there in the bottom left-hand area. We're going to click that and then just enter the number you want to take the square root of. In this case, it was 2,809, and you can see the answer is 53. The reason that's 53 is because 53 times 53 is 2,809. All right, so let's go ahead and unshare the screen for the moment. And now we're going to find, let's see if we've got room here. Well, actually, we're going to erase this, I think. So if you need, there's your chance to pause the video if you want to look at this. Remember, study the examples as we go until you have a good understanding. So this next problem, or next part of it, I should say, is for problem number 2 and number 5. So number 2 and number 5, same thing. All right, so we want to find the measure of angle T. So the measure of angle T. All right, so the measure of angle T, and we erase that, so let's put the T back there. So we know the lengths of 2 of the sides. Well, actually, we know the lengths of all 3 sides now. So we really could use any trig ratio, but they're telling us there to use inverse tangent, so that's what we're going to do. So the measure of angle T would be the inverse tangent of Well, what ratio? Well, remember, tangent is the opposite leg over the adjacent leg. We'll just abbreviate that. And so remember how we find the opposite leg and the adjacent leg. So if this is angle T, these are the two sides that form angle T. The opposite leg is the leg or the side that's not part of what forms angle T. That would be the 45. And the adjacent leg is the leg that it is part of what forms angle T. Remember, these are the legs here. So the leg that's part of what forms angle T would be the 28. So now we're going to go back to Desmos and find the inverse tangent. And we're going to round to the nearest whole number. So let's once again go into Desmos. And it takes a second for everything to share. Okay, and that should be up about hopefully soon. I think there we go. All right, so we'll start with the keyboard lowered. So we're going to bring up the keyboard, and then we're going to go over here to functions. And then inverse tangent is right here, tan with the -1, not tangent, but inverse tangent. And then we're going to enter our ratio, 45 over 28. So 45 divided by 28, because the fraction bar means divide, and we get 58.1 degrees. And so that's equal to 58.1. And of course, it goes on longer than that. But since we're rounding to the nearest whole number, I just want to double check. Yeah, nearest whole number. So here is the whole number or units place. The next number is a 1. Remember, 0, 1, 2, 3, and 4 are the stay numbers. So remember, when we round this, we can stay 58 or go up to 59. So again, which one is it? Well, since the next number is a stay number, 0, 1, 2, 3, or 4, it's a 1. We're going to stay at 58 degrees. So the measure of angle T, rounded, so approximate, is 58 degrees. All right, so that's our example for problem number 5. And let's see, let's unshare so we can see that clearly. That's hard to see that without. So what we did is the next number was a 1. 1 is a stay number, because when we round, the options are stay 58 or go up to 59. Since 1 is a stay number, we stayed at 58. And since we're rounding is always an approximation, so that's why it's the squiggly equal sign there. All right, so now we've got room here. So here's our example for problem number 3. And this will also help you with problem number 6. So the last thing, let's put the information we found here. We found that HT is 53. We know that angle T is approximately 58 degrees. So now we need to find the measure of angle H. So there's a couple ways we could do that. We could use another inverse trig ratio. But what they tell us to do here, which is the easiest way to do this, is to use the fact that in a right triangle, the sum of the two acute angles, meaning the two angles that are not the right angle, these two guys here, is 90. So if the sum of these two angles is 90, and I know one of them, the other one would just be 90 minus the one we know, the 58. So 90 minus 58 gives us 32. Is that right? Yeah, 32. And so the measure of angle H is 32 degrees. We can see that okay? Yeah, I believe so. So that would be the easiest way to do that. But again, since we know all three sides, we could use any inverse trig ratio as well. But this would be the quickest way to do it since we know one of the angles. All right, so there we go. We've solved that right triangle, and that's what you're doing on problems 1, 2, and 3, and then again on problems 4, 5, and 6. So it's solved because we know the lengths of all three sides and all three angles. And this angle is a right angle, so we know it's 90 degrees. All right, so now let's take a look at an example that will assist you with problems 7 and 8. And 7 and 8 is finding the area of a triangle. And you might think, well, that's something I know how to do already. Well, you might, but only if you're given certain information. So let's take a look. This example, again, is for problems 7 and 8. So normally, if we have a triangle, and what you might remember is base times height divided by 2. So if this was 10, this was 8. We could just say our base is 10, our height is 8. and 10 times 8 is 80, divided by 2 is 40. And we could quickly have the area of that triangle. However, maybe we're not given all that information. We're given some other information. So let's go ahead and take a look here. We have our example. We have this is 107 degrees. This is 12 meters. This is 10 meters. So if we wanted to use the traditional area formula for a triangle, we couldn't here, because the base, we're given the base. We have the base, it's 12, but 10 is not the height. Because remember, the height is that perpendicular distance from the base. And while this is almost perpendicular, it's not quite perpendicular. So that's not the height there, although it's probably somewhat close. So what do? Well, there's another formula involving the involving sine, and let's go ahead and put it up here. Let's actually do this over here. Area equals A times B times the sine of C divided by 2. So we see something familiar with the divide by 2 here, but what's in the numerator is very different. So what do A and B represent? So A and B represent these sides here. And again, it doesn't matter which is which because we're multiplying them, and the order that we multiply doesn't matter. But let's say this is A and this is B. C is the angle that's in between, or that's formed by those two sides. So we can see that we do have the angle that we need, because here are the two sides, and the two sides are in fact what forms this 107-degree angle. So again, you need two sides to use this formula. You need to know the length of two sides, and then the angle that's in between, or that's formed by those two sides. All right, so let's go ahead and substitute those numbers into our formula. A is 12, B is 10, and then the sine of C is 107 degrees divided by 2. And we're going to substitute, well, we are going to substitute it into Desmos. So let's go ahead and do that. And there we go. Desmos is up. And let's go over to the Desmos window. And so let's lower the keyboard, get rid of that. All right, so we're going to type that in, 12 times 10, so 12 parentheses 10 times the sine of 107, and then divided by 2. So let's do that again. We did that a little bit fast. So again, 12 times 10 times the sine of 107, and then divide by. Now, for divide, you can either hit the / key or just bring up the keyboard and press divide. And so divided by 2. And we see our answer there. And they're telling us to round to 1 decimal place. So we get 57.37. And so the options are, we're going to round to the nearest tenth. So the options are to stay 53.3 or go up to 53.4. We look at the next number. The next number is a go up number. Remember let's go ahead and unshare the screen so we can see that. So, and I think, there we go, we're back. So 53.3, the options are to stay 53.3 or go up to 53.4. The next number is a 7. 7 is a go up number. Remember, 5, 6, 7, 8, 9 are the go up numbers. And so we're going to go up to 53.4. Now, this is area. So we have a unit. It's M for meters. And remember, area is always in square units. So our answer, 53.4 square meters. And again, this example will help you with both problems 7 and 8. All right, that's it for this video, lesson 13.4. Again, as always, good luck with the work. Pause, rewind the video as needed. You're going to do great with this work. And until the next video, take care and God bless.